Hello everybody and welcome to the Multi-Medix webinar series on ultrasound probe testing. This is the third and final in this series on ultrasound probe testing, and tonight we're going to show you how to do advanced probe testing using your Multi-Medix ultrasound probe testing tool. As with the previous webinars, I'm going to give a 1-minute introduction dealing with some of the administrative aspects of the webinar, and then I'll be passing over to Jen and Darren, who you can see on the screen as well. Darren will be telling you about the advanced ultrasound probe testing for about 20 minutes, and then there'll be 10 minutes at the end with Jen for you to ask any questions. If you do have any questions, then please put them into the chat panel and we'll deal with them. For those of you that might be watching this live, this is being recorded. And if you'd prefer not to have your comments recorded, then it's okay to leave the webinar now, send your questions in later on and we'll deal with them. For those of you that are also watching this live, please, if you can keep your cameras switched off, it does help to reduce any lagging issues there might be. If you do have any difficulties seeing the webinar or hearing it, then I'm going to stay in the background and help with any administrative issues. Just put something in the chat panel and I'll see if I can help you. My name is Marilla Stevenson and I work for Multi-Medix along with the two other people that you see on the screen, Jen Reiner and Darren Woolley. Jen is our US sales director. She's worked in the industry since 2005, and some of you may well know her and recognize her from her time at Trisonics, which is a leading independent ultrasound service company on the East Coast of the States. Jen was in a senior position at Trisonics for about 15 years, and we're really proud to have her now with Multi-Medix. So I'm going to hand over to Jen now, who's going to tell you a bit more about the webinar and introduce Darren to you.
Okay, thank you, Marilla. As Marilla stated, I will be your direct contact for all your probe repair and probe sale needs. So I will send everybody a post-webinar email follow-up so you will all have my direct contact information. Feel free to contact me anytime with any probe requests or questions that you may have. I'm always available. I work alongside Darren Woolley, who is our technical director. Darren has been in the ultrasound industry for 25 years and is a biomed and electronics engineer by trade. He has published several papers on the subject matter and has also implemented our ISO 13485 accreditation within our facility. I'll be back with everybody at the end for a Q&A session, but let's get started and I will turn it over to Darren.
Hello everybody, thank you for taking some time to join us today to look at testing phased array probes simply and quickly. So I call that in the field or first line without any difficult test equipment. For those who've joined us on the previous webinars, we'll know that it's very commonplace for people to know how to test linear and curvilinear arrays, but today we're going to discuss how we can do that with a phased array which uses different beamforming. We just pretty much need our Multi-Medix test tool, which if you've not already got one, then you can contact Jen and she will get one forwarded to you. We'll also share with you our testing protocol, which is important to getting the settings correct. So I'm going to flip over to do the demonstration to an ultrasound system. So I'm just going to swap cameras. And hopefully you can see we have here a Philips CX50. Typical layout of a console, although it's a portable system, it'll demonstrate the principle correctly. So with all probe testing, it's a good idea to start with a little inspection. So I've got a Philips S51 phased array probe here, typically used in adult cardiac applications. And as part of the inspection, which is also part of our test protocol, we're just going to look at the various pieces of the construction of the probe and just check their function. You can probably notice this one has got damage to the lens, but we would always inspect the lens, particularly for wear or splits that can affect image quality, infection control and electrical safety. It's not uncommon for phased arrays to suffer from some form of delamination. There's quite high friction when they're used on the patient's chest on the intercostal spaces to get an image. And if it is delaminating, it's quite common. You can just push quite firmly on the lens material with your thumb, and if it bubbles up, it starts to delaminate, and that can start to degrade the image and the quality of what you're getting. We'd also inspect all of the joins on the probe, look at the strain relief, the condition of the cable. It's always a good idea with the cable to run it through your finger and thumb. You'll detect many more issues that way. Your fingers are very sensitive to picking up errors and defects that are there. There's a lot of micro coax cables present inside these cables, so they're very easily damaged and fractured. And it's quite common with the phased arrays, which are typically used over the patient on a bit of an angle. They get quite a lot of force here on the strain, so look out for damage and problems there. The next thing we're going to do, just following our protocol here, is we're going to make sure, first of all, that our probe is clean and dry in air. So please make sure there's no gel or anything else on the probe at this stage. The second thing we need to do is just select an appropriate preset. So I've selected in readiness for the demonstration adult echo. So it tells us at the top of the screen here, and that's a typical preset. And as you'll notice, as we've gone straight to how the user would find this machine, we don't really see anything akin to an air reverberation pattern at this point in time. So we can't really tell anything about the conditionality of the probe. So what we're now going to do is optimize the machine to make it easy for us to see a single line of dropout on a single element within this array. So what we're going to do is we're going to adjust our frequency controls. I'm just going to unfreeze this, and we're going to turn harmonics off. And then that's this control here. And then what I'm going to do, and it tells me there, I'm going to change over to single highest frequency. So it's going to display res here and here and here. Then we're going to just check that the swept gain controls are central. And we're going to ensure that we turn off any advanced processing. On this machine, we've got X-res. So we've just turned that off. You won't find compounding, which you will on the linear and curvilinear. It's not used by phased arrays. And then we're going to look at the depth. Now, this is one of the first differences between the phased array and the linear and curvilinear tests. With the phased array, we actually don't want to go shallow, which is what we did with the linear arrays to make a small aperture. We want to go to about 80% of the potential depth that this probe will manage. So I'm going to use the depth control, which is over here, and I'm currently set to 15 centimeters. And we're just going to see where that goes. So that'll go to about 25 centimeters. So if I selected 18 or 20 centimeters, that would be completely adequate and realistic for this probe. And what we're doing is we're making sure that as we go deeper with the focus and with our whole image, we're going to use all of the array, not just the center part of the array, to create the image with the beam forming. The next thing we're going to do is going to look at a focus. And on our linear arrays, we're looking at the focus being near the top of the image. And on this occasion, we're going to take it to the lower part of the image. So we're going to select a single focus, which is what we've got here. And we can see these little caret markers. And we're just going to use this control again. And I'm going to bring that down to the lower part of the image. So about there. So that's about correct. And then what we're going to do, we're just going to adjust the gain, which is our control here, to avoid saturation. So saturation is when we've turned the gain up to maximum and we see some noise in the lower part of the image. In the lighting conditions we've got today for the demonstration, it's not ideal. I can just see a little bit of noise on the screen. And what we're going to do is just turn that back a little bit. Now we're beginning to see some kind of pattern at the top, but it's not giving us any meaningful information like we had on the other tests. So now what we're going to do is we're going to use an M mode test to identify dropout using our test tool. So what we intend to do is we're going to be applying a small film of water to the lens, and we're in M mode. We're going to be taking our test tool at a 45-degree angle to put a very small surface area in contact with the surface of the lens, and we're going to sweep it across at the same speed as the M mode. And what that's allowing us to do is, if we are in contact with an element that's working, our metal tool will give us a white ring back in M mode. If we come across an element at any point in time that's not functioning, we will get some kind of black streak, and that will identify errors and non-functional elements. So what I'm going to do now is I'm just going to apply a small amount of water on the film on the lens. I'm going to turn M mode on, or motion mode as it's known, and you'll see we've got our sweep. So this is used in cardiac applications, looking at the speed and distance of moving items. So we look at the heart, the myocardium, the valves, and look at the motion, and we can detect if there's illness or irregularity. The next thing we need to do is a very important part. So what we need to do is bring the cursor for the M mode trace, which is controlled by the trackball, to the center axis. So that's here. And then what I'm going to do is I'm going to sweep across, try and do the same speed as my M mode trace, and I'm going to get a ring back pattern like that. And I'm going to hit freeze. And that's a perfect example of the kind of results we're looking for. So what I can see here with experience is very solid ring back in this first part of the array, and I swept across this way from here, and then I see some dropout because I've got vertical streaks where it's going light, dark, light, dark, light, dark. And what I'm able to see and know with experience, and from research papers that were written and published and researched by ourselves and Dr. Nick Dudley, is dropout within their array. Now, we know that dropout in the array is not easy to detect in the 2D imaging, but what we do know is it affects Doppler severely, and we also know that most phased arrays being used in cardiac applications are definitely used for Doppler measurements. Now, we always recommend, because of the operator may be getting slightly different results with the speed and action, you just repeat this several times, and the rule of thumb is that artifacts move in the results, and that's a very similar result, but defects don't move. So if we keep getting the same result several times over, and that's what I'm seeing there, we can pretty much identify this is definitely a defect, and it's not me accidentally lifting my tool off the probe. So what we can do is, we talked about how we could actually test something without the need for expensive test equipment. Well, using a typical first call report, which hopefully we're all familiar with, and we've looked at on the previous webinars, what we can actually see, this particular probe is a series of good performance, which is in this first result, and then intermittent elements running with no function and function. And that's why I've got these dark lines in this section. And then we get some performance back at the end. And that's enough for us to be able to confirm that we've got some kind of defect that requires action. Our protocols, like the curvy, linear, and linear, show examples of what a good result should look like, examples of what defects in physical inspection look like, and different levels of defects within results down to a single element being out. We've graded things green, red, and amber. So green's good and everything's good to go. Our red is related to take immediate action. And amber might mean you need to take further action, but you might not immediately need to remove it from service. So what we've got with a dedicated protocol, careful manipulation of the machine to remove processing that hides faults and put it into a mode, and our test tool and practice can see significant defects with phased arrays with very little time or effort or expense. So what I'm going to do is I'm going to bring Jen back in, and we're going to open the floor up to questions, and hopefully if we've got some questions, we'll be able to answer them.
Okay, thank you, Darren. Yes, so we can start our Q&A now. So if anybody has any questions, you can put them in the chat panel now. In the meantime, we had a few questions submitted beforehand. Darren, one of those is, how can we test matrix arrays? That's
a good question, Jen. We have adapted tests for two different types of matrix. So what I'll call perhaps is 1.5D matrix, or some people call them multi-row arrays. So that's very similar to the linear and curvilinear arrays, and we're considering running a advanced course on that as a webinar. So if you're interested, please let us know, and then we'll be looking at that. There are also high density matrix arrays, which we have adapted the M mode test for. And once again, we'd be delighted to run an advanced session on those. But there are adaptations that we've been able to research and demonstrate. So we'd be delighted to see if we can do an additional webinar for those.
Okay. And another one is, how can we find out more about repairs? And I can answer that one. We repair most major OEM makes and models. free loaners, free valuations, quick turnarounds, detailed reports. So feel free, I will be your direct contact, to contact me anytime with any questions or requests around probe repair, and we'll be happy to help you out and get those repairs in for you. And a last one also is, are you doing future webinar sessions? So Marilla will be sending out an email for some feedback, and we do plan on doing future sessions. We would like your feedback on the ones that we've done, and maybe some feedbacks on topics that you would like to see. So that was another question we had. So please keep an eye out for any future sessions that we may post in the future. Looks like those are pretty much all the questions for today. I hope everybody enjoyed the session. And again, everybody's test tools will be out and you should be receiving them shortly. And please contact us, any questions you may have for our technical team, for our sales team. We're always available. Hope everybody enjoyed and have a great day.
Yeah, thank you, everybody. Thank you, Jen.
Thank you.
Goodbye.
Bye-bye.